Today on How It's Made Shark Week Edition. Surfboards. Diving regulators. Scuba tanks. And water skis.
Surfing is an ancient Polynesian pastime, first documented by Europeans in the 18th century. In the 1920s, the sport spread from Hawaii to the beaches of California. Back then, surfboards were made of solid wood. Today, they're made of lightweight synthetic materials. Serious surfers have their boards custom-made and engineered for the types of waves they'll be riding. At the board's core is a piece of polyurethane foam with a wooden strip down the center. The factory shaping specialist inspects the board and checks the foam for defects. If all is well, he cuts the board to the right length. Then he chooses a board shape template from his library and traces it. Then he saws along his pencil line. Using a planer, he refines the starting shape to the customer's specifications. When he finishes, he checks to make sure everything's symmetrical. Next, he shapes the edges. With a power sander, he flattens and smooths out the surface, then follows with a fine sanding by hand. Before releasing the foam core to the next department, he checks the dimensions, thickness, contours, and the smoothness. A lamination specialist preps the board to receive its first layer of fiberglass. He masks the top, called the deck, to shield it from the resin he'll now apply to the bottom. He lays down the first fiberglass cloth, leaving a 3-inch overlap along the perimeter. Next, he spreads polyester resin that's tinted to whatever color the customer ordered all over the fiberglass cloth. He folds the overlap onto the deck, then grinds the corners flat. He flips the board deck side up and trims the overlap. Next, he covers the deck in 2 layers of fiberglass. In between them, he pours clear polyester resin. Then positions company logos printed on rice paper. The resin soaks the paper, embedding the logo. Then, another layer of resin-coated fiberglass. Once that dries, he applies yet another coat of resin on both sides of the board. Using a router and template, he cuts a hole for the box that'll hold the surfboard's fin. He fills the hole with black resin, then inserts the fin box. Now, a sanding specialist takes over. He grinds the box flush, which opens its fin slot. Then he gives the board an overall sanding to smooth the surface. Next stop is the paint room. The painter uses masking tape and an acrylic paint pen to decorate the surfboard with black pin lines. Once they dry, he masks the board and airbrushes in a white pin line. Once dry, he applies a finishing coat of resin over the entire board. Now, a polishing specialist steps in. After a fine sanding, he buffs the entire board with polishing compound, producing a slick, high-gloss finish. The factory ships the board to the surfboard shop, where the customer chooses a fin from the many models available. The fin screws into the fin box. And dude, the board is ready to go. The diving regulator is a lifeline when you're underwater. Invented in 1937, this device converts compressed air from diving tanks into a breathable form and delivers it to the diver via a mouthpiece. And that means once you've taken the plunge, you can breathe easy. The 2 main parts of a diving regulator are called stages. Computerized tools transform a piece of brass into the first stage housing. They carve a cavity and holes for attaching hoses and other components. A blade cuts the part to size. Then a drill creates a space for the pressure reduction valve. This end also gets holes for more attachments. Another tool sculpts the side to reduce the weight of the part. Sliced in two, this is how the first stage housing looks inside. After it's been chrome plated, they insert plugs for the holes that will later be used for attaching gauges, hoses, and other parts. The fitting that connects the regulator to the scuba tank goes into a holding device, while the technician assembles a special valve for keeping salt water out. He fits a piston onto the end of a spring, and then slips the assembly through a hole to confirm it's the right size. He installs a filter on the other end of the spring. Now he inserts the valve in the fitting. He secures it with this rubber ring, pressing it into a groove in the fitting. The valve appears to be firmly entrenched. He presses it to confirm it operates correctly. And he pumps water into a bunch of these fittings to confirm the valves inside are indeed watertight. He attaches a rubber cover and a chrome-plated yoke to the fitting. Then installs this assembly in the housing, using a long-handled socket wrench to get the right torque. This yoke swivels to give the diver some flexibility in attaching it to the diving tank. He now assembles a crucial component, the high-pressure reduction valve. Installed inside the first stage housing, it converts high pressure to medium pressure. He caps the yoke with a knob, then inserts a pressure-sensing mechanism at one end of the first stage housing. He covers it with a rubber membrane. As the diver inhales, this membrane will trigger the valve to release more air. The diving regulator's first stage is now complete. He just needs to calibrate the pressure reduction valve inside. He hooks it up to compressed air and adjusts the valve so it reduces air pressure to a precise level. He immerses it in water to test for air leaks. There are a few bubbles from plunging it underwater, but nothing that would indicate a problem. They now move on to the diving regulator's second stage, which will convert the medium pressure air from the first stage to a breathable level. The diver's breathing will trigger this diaphragm to open the air valve. He attached a protective cover, and he's ready to install the second stage valve. After he inserts it in the second stage housing, the technician makes an initial adjustment. Then, using a special tool, he precisely calibrates the valve. He removed the diaphragm for the last steps, so he reinstalls it. Then it's over to a guy with an ear for the job. As air is pumped into the second stage, he listens for hisses that would indicate a leak. Satisfied there are none, he hooks the regulator up to a device that simulates breathing and measures the effort required to inhale. If it checks out, they link the two stages with a hose, and this diving regulator is now equipped to handle the pressure. Underwater exploration was a shallow experience until scuba tanks were developed in the middle of the 20th century. Filled with compressed air and attached to a breathing regulator, scuba tanks enabled divers to stay underwater longer. This invention took diving to a whole new level. Scuba tanks are a way to bottle the air we breathe and take it with us underwater. To make aluminum scuba tanks, they start with solid cylindrical chunks called slugs. The aluminum alloy slugs tumble around in a perforated rotating drum, which takes them through a series of chemical baths. The baths clean and treat the surface of the aluminum to prepare the slugs for forming. The operator loads the slugs into a feeder system that serves them up, one at a time, to a hydraulic extrusion press. An extrusion piston forces the slug into a die inside the press. It hollows and stretches the slug into the shape of a scuba tank. It takes about 1,300 tons of force to transform a solid short chunk of aluminum into a longer hollow cylinder. The shaping process itself generates heat, making the aluminum softer and more malleable.
The press establishes the outer diameter of the tank, the inner one, and the base. The process takes just 20 seconds. The freshly formed cylinder now spins as the roller applies a lubricant to the open end. The machine ejects the cylinder. Then it's over to the hydraulic neck press. This press forces the opening of the tank into a die to narrow it substantially. This establishes the basic shape of the scuba tank neck. It still needs more work, but first, the tank shape must be firmed up. They heat treat and then quench the scuba tanks in cool water. The shock of the rapid cooling hardens the aluminum. Back to the neck now. A spinning computerized cutter shortens it. Then another cutter moves in. Filings fly as it carves excess metal from the outside of the scuba tank neck. A computerized drill widens the neck hole and cuts a pocket for an O-ring seal. The next tool carves a thread into the inside wall of the neck. The threaded profile will allow for connections to an air fill-up valve and to a breathing regulator. Every scuba tank undergoes a test to measure tank expansion under pressure. They fill each scuba tank with water and place it in a test jacket that's also filled with water. Testing equipment increases the pressure in the scuba tank, and the tank expands, placing water from the test jacket. By measuring the displaced water, they determine the rate of tank expansion, and if it's acceptable, the tank moves on. A scuba tank now spins against a sanding belt. This sanding gives the exterior a brushed finish, which some divers prefer. They etch the serial number and other information onto the upper part of the tank. For a more colorful look, the factory applies a vibrant translucent powder coat to the brushed finish. The finish is purely aesthetic. Aluminum doesn't rust, so a natural finish would weather underwater conditions as well as the powder coat. They bake on the powder coat, giving the tanks a glossy look. These aluminum scuba tanks are now ready to take the pressure. Life is sure to be one underwater adventure after another. Water skiing was invented in 1922 by an American teenager named Ralph Samuelson. With his brother pulling him by motorboat, he experimented first with skis made of barrel staves, then with snow skis, then with skis he had made out of pine boards 94 inches long. This type of water skiing is known as slalom, winding through a course on a single water ski, 1 foot behind the other, in boots mounted to the ski. The core of these top-of-the-line competition slalom skis is high-density PVC foam, exceptionally strong yet lightweight. A computer-guided machine cuts the ski shape, then pockets to receive various components. Workers flip the core upside down, and the machine shapes the bottom. Workers then turn the core right side up again and fill the pockets with glue. They insert an alignment tab in the tail pocket to help correctly position the core in the mold. They install fiberglass reinforced nylon blocks in the others. These will anchor threaded inserts for mounting the boots and the ski's fin. Now they begin building up the water ski with multiple layers of carbon fiber, an ultra-strong fabric. They apply the first layer to the bottom, wrapping it around to the top. This will prevent the ski from twisting. After stapling down the carbon fiber and trimming off the excess, they saturate it with resin and apply carbon fiber to the top of the ski. Depending on the model and its performance specifications, they wrap the core in up to 7 layers of resin-saturated carbon fiber, controlling the flex in select areas along the way with additional patches. Then they top the ski with a layer of woven synthetic fabric to prime the surface for the decorative graphics. On the bottom of the ski, they apply a sheet of super lightweight polymer. It creates a white background to highlight the printed polyester sheet of decorative graphics. They coat it with a special resin that cures into a hard, hydrodynamic surface that increases the ski's speed. The graphic design that decorates the top of the ski is printed on nylon. They mount it to the top part of a ski-shaped mold. Then lay the wrapped core into the bottom part. A heated press closes the mold, compressing the contents under high pressure for 9 minutes. This bonds the layers, forms contours in the ski, and adheres the graphics. The pressure squeezes out excess resin along the perimeter, so once they remove the ski from the mold, they cut off the excess with a bandsaw. Then, with a custom-made router bit, they precision trim to exact specifications. Next, a 3-phase filing of the ski's edge. First with a large file, then a small file, then with either a razor blade or medium grit sandpaper. Then, with the help of a template, they drill 18 holes into those fiberglass reinforced nylon blocks in the core. They screw a threaded insert into each hole and it locks into the block. There are more inserts that are actually required for mounting the fin and attaching the ski boots. This gives the skier different positioning options. Now the last edge sanding with fine grit paper. After wiping down the entire ski with an alcohol-based cleaner, they install the final and most important component, the fin. It's made of aluminum that's chemically treated to be corrosion resistant and ultra durable. The fin's position critically affects the ski's traction and stability, so they use a micrometer to measure to the millimeter, securing the fin precisely where the design engineer specified in the performance maximization sweet spot. Nonetheless, competitive water skiers typically readjust the fin to their own preferences in hopes of leaving competitors in their wake. If you have any comments about the show, or you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.